let's see here. Share this. Okay. All right. Let's see. Tell me if you guys can see it.
Not yet.
Not yet.
Now I can.
No.
Yep, now I can. Yep, I know the one
Oh.
that paper.
I'm looking at the directory and I'm thinking it is the I think it's the Hajim, the plasma electromagnetic sky paper. But if here's another way to get to it. If we go to here, and what would it be in? It'd be EU General, I think. Other EU Fractal Earth, maybe? No. Hold on. Hold on.
Nothing in there yet.
No, it's not.
This series, something popped up.
Hold on.
Electric wave. Here we are.
No, I'm going to, let's just do a search for geology and see what comes up here. I'm pretty sure that I did.
Put it in.
That the paper is embedded in. That's what I'm trying to find is the page that it's embedded in. Because then people can view it without having to go and download the paper. Of course, they should download the paper. A good idea. All right, so we got a thing here for the planet is electric.
Galaxies.
Actually, the paper. I'm not sure if I embedded the paper here. No. I will. What I'll do is I'll go in and I'll put a link. I'll get this to link over. Oh, maybe the electrogeology page. Did I create an electrogeology page yet? No, I haven't done that. I haven't filled that in. All right. Well, we'll do it the so-called hard way. We'll just go to the directory and click the link and go to the page. Go to the academia. I like them when they're in the embed though, because the embeds actually have motion. So this is the one. I can't remember if I did this one before the Atlantis paper or after. And what I did here is I included a lot of the research of other people about the way things. Of course, this is kind of famous. That's been seen. That's NASA.
You did a talk on that with Greg, didn't you?
I did a couple of years
ago.
About
2 hours. Yeah, I've listened to them.
Yeah, that was a good one.
Yeah.
Then I have Jurgens and Donald Scott, and this is my work about the electrothermal vine, but this is the Sapphire project results. Sapphire phase 1. Here they are, phase 1 of Sapphire. And then, but there's a specific one that brings, because here's Donald Scott again. Then I did this. I showed how much better Birkeland currents are at carrying energy out at great distances. Here it is. So in a new paper, what I would have done is included the animated GIF for this. But on academia, you wouldn't be really able to see it anyways. But the way I see their misinterpretation of these kinds of things, this is all supposedly gravity, and then back here, this is all supposedly the magnetic fields. The way I look at it is actually the opposite. That these are accurate measured electric currents in which the magnetism is following at 90 degrees out of phase. And the reason why I feel that is accurate, aside from the other works of people like Donald Scott showing the coaxial cables and the counter rotation and the 90 degrees out of phase there, and also coming out of the active galactic nuclei, is very specifically, and this one I definitely embedded in the magnetic universe.
Is that how magnetism shapes the universe? How magnetism shapes the universe?
Right. Right. So these kinds. Here, I could have just.
I've got a video for it.
That's where it is in the magnetic universe page. I've embedded it. The Magnet U paper and the PEMS paper are both embedded here. But very specifically, in the magnetic universe paper, when we go to DeCinti's work, let's see here. Looks like page 39.
There we are. Magnetic universe theory. Page 39. Is it?
Yeah, page 39.
Magnetic universe theory, page 39. Yeah.
And in there, I started going through DeCinti's research, and I distill it down because, you know, his stuff is long and tedious and lots of vector math, and you know, it's going to be tough for a lot of people. What I reckon is the heart of it is in his Vortrix algebra. Actually, is that correct? The page 39. Let's see here. Vortrix algebra. There we go here. Isn't quite. Oh no, page 60 is his Vortrix algebra. It's a big paper. It takes a minute to load. A lot of images. You know, I create these products for people to use. What's funny is someone got really butthurt the other day because I said that it was fake news that the sun is a ball of burning gas. And she got really mad. And then she said, well, you cited your own self. I was like, well, no, I cited a page out of an FAQ, of which there are 16 mainstream papers cited with the electric currents in space of all the scales. But she didn't want to, you know, listen to that. And I thought, well, this is the whole point of creating these products, is for the public. So kind of funny.
And you always have the references in it and on it, on the bottom of the page. So your reference would have said where you and why, which
exactly. No, so I
tells you, I put this here. Yeah, I put this here because this means this is what is current or has been done, and this is what another one. Yeah.
All right. So this is what I was saying about DeCinti and his edge currents and eddy currents. You know, the idea of the summation, more or less everything in the center is canceling out, and it's the edges that is where things matter. And that's what they have shown with like conducting wires. It's not the gauge of the wire in terms of size or diameter. It's the gauge of the wires in terms of surface area that matters. So, you know, just interesting effect. So here we go. So in his Vortrix, he has identified that the imaginary number, which is the square root of -1, is this matrix, and it's an inverted identity matrix. And then he steps through and he proves, using that identity matrix, that he's able to get the results without all the hand waving that was done by oh God, who was it that came up with the complex number scheme that we use?
Oh, Max. Oh yeah, the Scottish guy. Yeah.
One second.
Hamilton.
Huh?
Hamilton.
Okay, yeah. So in his in the whole Vortrix paper, he steps through the hand waving there, and he says, how is it that you can FOIL but not multiply out the outer and inner portions, and you're only multiplying the scalars and the of, you know, the scalar real numbers by each other and the scalars of the imaginary numbers by each other? That doesn't work. That's not algebra. It's basically a giant con. And then I know that we're all conspiracy theorists here, but this is maybe one of the worst cons that's been pulled. It's sort of analogous to the Kirchhoff, you know, so-called laws of thermodynamics that Robitaille has pointed out that have misled everyone.
Yeah.
Or Einstein dividing by zero and getting away with it. This is on that level. So what he said is, here's the problem: is it's not that, you know, the square root of -1 doesn't exist. It's that it's really supposed to be these rotated matrices. And then he's gone through and actually set about proving that you can use this identity matrix here to solve the electrical equations. Now I'm just showing this. His whole paper is, as far as I know, he's kept it private. I've cited here Vortrix Algebra, revision 1.2, 2018. You know, it's I would personally, I'd like to see him put it on Academia or ResearchGate, because it's one of those things. But many mathematicians have done that kind of thing. They've kept their work secret until they died, and that has happened plenty of times. I don't know what he's holding out for, if he thinks he's going to make big money out of it or something. I have no idea, but it is really actually very important because it matches the same concept of the rotated 90 degrees out of phase, because essentially what's happened here is he's, if I remember correctly, he's inverted it and he's rotated it 90 degrees. And that led, his work led to me creating the tool. If we go back to the directory, the matrix, a lot of people don't notice this, but on the directory of my papers, if you scroll down, there's actually a set of tools down here, and there's a matrix multiplier. And that came out of the need to do some of the rotations. It's a spreadsheet. It's not as good as, of course, using Symbolab or something like that, but it does, you can visually, you can see the results where you click this and you can click a different menu option and it rotates around. So, you know, when he was going on about this, I'm not so sure his own audience understood what he was talking about. There were a few mathematicians and physics guys. Now, his new electromagnetism, somebody took it to phys.org and they posted it, and they said, okay, can anybody prove that he's wrong here about Faraday, about Maxwell? No one could. So instead they attacked Robert DeCinti's character, which they didn't know who he was. So all they could do was say he was a crank, he's a quack, he's a blah, 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 blah. But in the end, you know, going back to page 39, all this stuff here from 39 to 44 here, this new electromagnetism, they couldn't debunk it because it contained the Maxwell and it contained the terms that were missing. And he's been doing the experimentation in lab. He's a signals engineer. So he's all like RF and that kind of thing. And it contained the missing information that made it more precise. So there was nothing to attack because it's just a better model. It's a more cumbersome model. You can see here that you've got these extra vector dots in the equations, but you know, I reckon it's pretty freaking brilliant because he's talking about the how to deal with the ether, how to deal with gravity. You know, what would ether particles actually behave like? He's the only one I know who's put an anatomy to this stuff. Ken Wheeler he'll say a lot of words about the anatomy of it, and he'll boil it. Everything is, he'll do his thing where everything is conductance and capacitance and dielectrics, and you know, he'll do that whole thing. That's not an anatomy. And the SAM people are, of course, they talk about the ether, but they focus, their best work is in the atomic model and the platonic solids. But this is the guy, I reckon, who's actually done it. And so there's a video I want to highlight on the gateway, if people will go. And it is, well, he has his own page somewhere. But there is it might be on the back, on the Magnetic Universe page. I'm thinking about it.
Plasma, electricity, and magnetism.
Let's see here. One of the pages somewhere has his debunking of Ken Wheeler's idea. And I love that, you know, there's never been any, like, you know, drama or anything. But what he just did was he just stepped forward. He said, so, you know, you have this thing, it's very mysterious. Ken Wheeler's a lover of mysteries, just like I am. But DeCinti explains it with edge currents. And it's been a while since I watched the video, but he explains it with edge currents and the ether and the magnetism and how it all kind of rolls together. I am trying to remember which page was that. It's not in the plasma. He doesn't do anything with plasma. That's the one thing about his work. He's not. It would be under the other EU, that's for sure. If he has a page, yeah, he does. Distinti. Let's see here. And I hope people do support his Patreon. You know, I did for a while. You know, and I have his thesis linked here. I have some of his information on the Vortrix. You know, he has an entire series of these things called the what are they called? The oh man, here's the thing about the Vortrix algebra down here, and people can click these and make them bigger. Oh, here it is. Here it is. So the theory, hypothesis, experiment discussion. This video is, in my opinion, groundbreaking, and is completely overlooked by everybody, including the Electric Universe people. When this video came out, they should have been reaching out to him. And they should have been saying, this is the same thing when I found the Thunderbolt, right? They should have been reaching out to me. When this video came out, I thought Ken Wheeler was going to have a meltdown. Nothing happened, which is fine, which means it went way under the radar. And that tends to happen with things that are true. I don't know why that happens. And you know, is the devil in charge of the universe? I have no idea. But I will say that, that this video, I reckon, may be the most important thing since Steinmetz discovered hysteresis. It is, to me, one of the hidden aspects, and I think it's on about what Robert is trying to get at. But the difference here is Distinti has put the mathematics to it, and I think that's very, very important. That's my personal opinion, is that we need to be able to do that. So if people would you know, go to the epmcgateway.com. Go to here, click the arrow for the general, go to other EU, go to Distinti's page, or you can do a search for Distinti and then watch this video, or you can go to his YouTube directly. And it's distinti.com is the name of his channel, distinti.com, and subscribe to him. And if you feel like, give him a Patreon. I mean, he's an independent researcher. It would be great if he had all the time in the world. He has this entire simulator that he uses. It's called physics. The guy is, I reckon, one of the hidden geniuses of the day. I really do. So hopefully people take some time and go and look into his work. And that's more
totally.
About this.
Totally, yeah, fantastic. I followed a little bit of the discussion about using this, using these imaginary numbers to solve these matrices, and yeah, it's great, really. It's kind of,
think about it. There is no imaginary number. Now, can we use the A plus JB? Can we continue to use it? Yeah, we can continue to use it. It's gotten us decently far in terms of electromagnetism, but Veritasium puts out this whole video about the imaginary number, and the story is great. The history is fantastic. I love learning that, but unfortunately, what he does not know is that is just a model, that there really isn't an imaginary number. It is just various forms of matrices. And so when I eventually write that MIMS paper about bags of ether data, it's really going to be a discussion of matrices, but there'll be fractal matrices, there'll be nonlinear, they won't be in the simple shapes like we were just talking about. And this is groundbreaking research right here. This identity, to me, this is Nobel Prize worthy right here, right there.
How could you build a test kit for it, a test bed for it?
He's got all that. That's what that physics software does. He's got all that stuff. The problem is the guy's paranoid and he doesn't put it out. He's worried to be Velikovsky, just like everybody else. I mean, that one guy put his stuff up on phys.org, and I'm sure that somebody sent it to Distinti the responses. I mean, it was vitriolic. It was pathetic. It was, again, it was excoriating. It was practically, they would have burned him alive at the stake if they could have. And of course, I'm not going to link those kinds of things. Ben Davidson's the only one I link any kind of rebuttals to, because I think he needs it. However, Distinti deserved better than that, and so does Crothers and Robitaille. Crothers can handle it, but Robitaille is a very sweet soul, and it's really a shame the way that the scientific community has responded, rather than just listening to what the man is saying. You can watch his videos. If people aren't aware, I mean, viewers here, again, go to the PIM thing, and let's see here. Go to not other EU. Let's see, where is Robitaille?
Professor Dave.
There he is.
Robitaille's brilliant, yeah.
Oh yeah, but this is an important thing. These playlists, the Laws of Thermodynamics playlist, is essential. Now I've embedded those videos here for people for the convenience. Because it is absolutely essential to watch all 5 of those, and it's really absolutely essential to watch the videos with the experiments, and only people who are embedded with scientism, that they don't even know that they're part of a cult of scientism, would sit there and tell you to not trust your lying eyes, because the experiments are straightforward and conclusive. Now they can go back and do, take it to a lab and spend $500 million, and just like they would on cat farts or something like that, and they're going to come with the same results. Robitaille, in the terms of the annals of history, I'm going to make sure that I engineer stuff that he is given his credit. These videos right here with the thermography, that he's given credit for this in the far-flung future, in 1,000 years, when we're a stage 3 society, they'll be looking back on Robitaille, and they'll call it Robitaille's rules. And it's really unfortunate that we live in such a barbaric age where people can't just look at these 5 videos, look at the 3 experiment videos, take the time. I mean, they're not that long. I mean, they're 7 to 10 minutes long, right? And understand them. And of course, a lot of people, they can't understand because they don't have a background, which is totally forgivable. It's what's not forgivable is to then slander this man and say, well, he's a nutball because he thinks the cosmic background radiation comes from oceanic signal. Okay, well, but there's an entire satellite dish that showed that is true. So they go.
You there, Ramon?
Yeah, I got cut off there.
He's
Go on,
still here.
And they slander the man, and then they don't even address the work. And they did the same thing with the Distinti, and that's why I don't go on phys.org. I don't bother with phys.org or with any of these Michael Shermer type people, because they're not serious. And I would say that to Michael Shermer's face.
Well, I think we're just going to put out our own media. Put out your own media, and they've got to either rebut it, put it in front of them, get the dialogue going, the discussion, and if they're strong enough, they can rebut it. Or if they can't, then you get stronger and stronger.
That's the problem, is that they would rather hold on to their belief system that they previously had. Now, I went through that phase. I was lucky. I already had a pair of books on the shelf that I said, well, if this EU stuff has any merit at all, boom, it'll be. And sure enough, it was in both of them. And I mean, I was like, how do you miss it before? I reckon that it's not just about having Electric Universe eyes. It's about having the willingness to say I'm wrong, or I might be wrong. I kind of knew there must be a unification between my science, my Chinese science brain, and my electrical engineering brain. Right. And I didn't learn anything about plasma in electrical engineering college. It just wasn't a topic. Everything's computers and software. And then we had power classes, and we weren't encouraged to love power. OK, the classes were crap. The textbook was crap. The equipment was 100 years old. It wasn't, there was no investment. They don't want you to have power. And everything was signals and software, period. And so I reckon that, my great ability is to say, okay, I could be wrong about this. That started back when I was an atheist doing martial arts. I said, and I debated a theologian, and he impressed me, and I couldn't debunk him. And I said, you know what, I might not know things. And then the first time I felt chi at a distance from more than 20 feet away, I thought, there is something going on here, and I need to know what it is. So I went from being, an atheist, total standard model, just over time. And then eventually I got to the point where I have these two worlds. I have the Chinese science world, which is telling me something really special is going on. And all I can do is go, oh, quantum this and string theory that. And then I have this electrical engineering brain, of which everything I need to have take through, and it's the scientific method, and you have hypotheses, and science is about falsifying things, not about proving things, which a lot of people don't know, because in scientism it's the opposite way, right? I've proved it exists because I wrote a computer program that went and found it. It's like kind of that's not how that works. So I went and I tested it, and lo and behold, the electric universe was better. Now, as I continued the research, especially from the mythic end, I found out they didn't have the answers either. But I reckon if people aren't willing to just ask the question, and Robitaille asked the question, is Kirchhoff's law true? And then he shows you it's not. And Descenti did the same thing with the imaginary number. And the imaginary number is a place-holding model, period. It doesn't exist in its own separate context. You can continue to call it the imaginary number. It's really kind of funny that so many mathematicians who are probably way better at mathematics than Robert Descenti missed the potential answer. But I reckon that they didn't know because they're mathematicians and they didn't study electromagnetism, because only a person like Henri Poincaré would have studied the right-hand rule. And so I reckon that those are few and far between mathematicians. But if you took Descenti's work to Henri Poincaré, just imagine the kind of outcomes we could have had. I reckon he could have finished relativity. He could have finished so-called gravity waves and shown that they're actually electric waves. I reckon that he could have laid the groundwork for general relativity if he didn't himself go forward. But he died. That's just the sad truth. He died.
Yeah, now the work that he was doing, Poincaré, I believe he was talking about the great attractor at the end of his career. Is that correct? Or was that,
I do believe so. There is a wonderful wiki, one of the rare wikis that are just perfectly made. There are some in the Chinese sciences that are just unbelievable. Whoever wrote them, it was a work of passion. And this is one of those wikis that is just an absolute work of passion.
Yeah, it was really onto something, Poincaré. Well, really was.
It's unbelievable, and he was way ahead of Einstein with the E equals mc squared. Of course, it wasn't E equals mc squared; it was E over c squared equals m. And he's gotten no credit in the public eye. I'll meet people in the alt stream who will tell me that Einstein stole it from his wife, which there's no definitive proof of that. And I'm sitting there going, well, it doesn't matter, because she read Henri Poincaré. Everybody was, on about, but he had given up mostly because of his disgust with the idea of dividing by zero. Now, the interesting thing is the universe is also not dividing by zero. So look at this. You guys can still see the screen?
I can't actually, but
okay. Hopefully the audience can still see the screen. But this focus spiral looks a lot like what Descenti's talking about with his ether spiral. But when Gareth goes through his videos, what do we always see? The center is never in the center. It's always off center. There's an asymmetry every time. The universe takes the ideal and then through the approximation moves it off the center, because
there's a Lagrange point, isn't there? Is that?
But it's not just about the Lagrange point. It's a consistent. When these Eric Lerner pinches, or these Markland convection pinches are happening, where the Bennett pinching is happening, and it's all compressing together, the filaments go off center a little bit. Now, here's an interesting thing. If you go back and look at the Avebury, here, we'll pull it up. We're freewheeling. Avebury mounds. What we really need is the above view. I like the mounds, but let's see here. Where's that famous? It's a very famous diagram. I'm getting a whole lot of hinges here. See if I get better results and change the spelling. Ah, here it is. Look here. Now this shape was revisited at Stone Mountain in Georgia and at Portsmouth Earthworks. And what do we know? The two approach each other and then go off the center. So here's the trail in. This is
I can't see it.
You can't see it?
Yeah, I can see it. Come on.
You can see it, can you? I don't know. It's because I joined after or something like that, maybe. So it's not letting me. I can't see any of you guys or anything. So.
Sharing, and then I'll hit. All right, let me know if it.
I've got it back. You got it, Nick?
What do I do? Join up.
You should.
I keep pressing join call, and I just get an icon with NG on it, me. So that's all I can see.
No, what you should do is press the red one and get out of the call and then come back in.
Yeah, that'll work. We'll just hang out here until you come back.
Okay, yeah, we'll wait for you.
I'll try that.
Yeah, because there's two of us, you don't lose the call, do you, Ramon?
What'd you say?
Because there's three of us, you don't lose the call.
Right, correct.
You can come and go as you please.
Correct. The way the world's so subtle barb at modern society there.
Yeah.
I reckon if people would just support freedom, but then take the responsibility to educate themselves and act in an educated manner.
But that might not be safe.
I love this. The verse of the day, Galatians 5:6. For in Christ Jesus, neither circumcision nor uncircumcision has any value, of course, because it's materialist. And the only thing that counts is faith expressing itself through love. Are you back?
I am, yeah.
Okay. Can you see the screen?
No. No.
Well, that's right. Let me try, and I'll.
It's probably me. I've got Skype set up. It's probably I can get hold of. I've got your website open. I'm looking at the magnet stock. I've got an EPMC document open.
I'll paste in the chat the link to the.
Okay, yeah, that'll work. Yeah, thanks.
Okay, so when we look at this diagram, of course, we're not in an orthogonal view, and neither do we need to be. We can see the trail in the people in this area. I can't remember which part of the Isles is Avebury in.
Well, no, Avebury's on a plain now. It's in Somerset or Wiltshire.
Somerset. Okay, Somerset.
Yeah.
All right. So I reckon the people in Somerset did a fairly good job of marking the trail. Now, when the two come in, which of course these are either going to be, it's the same motif. They're either going to be the Jupiter Saturn interaction, well, proto Saturn, or I reckon it's probably actually Mars and Venus approaching each other. I haven't looked at the dating to see, how good the dating is. Feel free to do all that and tell me if you think the carbon dating is any good. But you notice when they trail in, the center is here. and they're rotating around a barycenter over here. Nobody ever notices that these trails aren't going directly to the so-called center, or the, on the sides of the middle oval there. They're not exactly on. This asymmetry is everywhere and no one is talking about it. Gareth has mentioned it briefly, but I don't think that he's gone gaga about it. And yet it seems to be incredibly important. The other one, the other big one is, of course, the what's the designation? The measure 83. Is it 83? M83?
93.
Is it 83?
Is what 83? Sorry.
The black hole, so-called. Yeah, I think it is M83.
Oh, I see. Right.
All right. Okay. All right. When we look at it, I'm going to pull up this is of course the simulation here. They've added a little bit of wispiness. Here's the actual computer image that was released. When we look, and they don't want to talk about this because it would violate their black hole theory, the center of it is not in the center of the entire diagram. And that's incredibly important. So they go, oh, well, the accretion disk is accreting more on one side. That's totally a fallacy. There's nothing in the mathematics about black holes that would suggest that that's likely. This is what the mathematics of the black holes would suggest: a perfectly round black hole. These are all, of course, simulations. These are not photos. I want to be clear to people. These are not photos. These are artistic renderings of data that is coming back, and they are paying artists to create these.
Where am I looking now? Where am I looking, please, Ramon?
Oh, this one's a Smithsonian search. Yeah, I just did a Google search for M83, and then I ended up finding
I see, Phil.
Smithsonian. So the black hole mathematics says that it should be exactly in the center, and that everything
180 degrees apart.
The lensing should be perfectly symmetrical.
Yeah, there's patently nothing there. There's patently nothing at all there. And that's why you can see galaxies through the other side of it, which are meant to be gravitationally lensed. You can see right through it and see galaxies the other side.
Okay. So they create this image. It's not a photograph, people. It is an image composed from data, and then they eliminate more than 99.9% of the data, and then they parse it together. And then when they parsed it all together, because that, as far as science goes, that's about the only thing about it that was done correctly. It doesn't come out symmetric at all. And the so-called accretion disk is not performing the way it should. And we are not seeing macro lensing at all in this image.
Yeah, it's hot on one side and not the other, according to this picture.
Exactly, which is exactly what you would expect in a plasmoid.
Yeah,
and
but not in a black hole.
The fact that it's not symmetric. In fact, I have a ruler here, and we're just going to use the image that I have, the box one here. We'll open it in a new tab.
No, what they're saying is this is glowing gas around the perimeter of the black hole. It's being excited energetically because it's being sucked that fast, isn't it, together? So
according to this, the height of it from the orange to the orange here is about 13 and a half. So at 16 and a quarter, at 6 1/4, you should have this thing on the center. The problem is the center is at 5 1/4, and that's height wise. Okay, then width wise, we'll just use the outer the outer of the orange, not the outer of the red, because we'll just give them the benefit of the doubt that all this extra gas is just all around. So according to this, it's now 15 wide. So it's 13 and a half tall and 15 wide. So it's either not perfectly orthogonal as they claim, or it's not perfectly symmetric as it should be according to black hole mathematics. Either way, boom, you already are having debunking going on. Okay, and the center is not located at exactly 7 1/2. The center is located here at 7.75 centimeters. So it's not even remotely there in the center. So if the universe does not want you to divide by 0. Poincaré was not wrong. The problem is he was pre-plasma. There were no experiments at the time. Birkeland's Torellas were the first experiments, and those experiments came just after Poincaré had died. And so there was no way for him to have seen how the universe responds. There's a famous equation called the Dirac delta equation. And basically this Dirac function, you have an arrow, a vector that starts at 0 and goes to infinity, positive infinity. And then it has no other function anywhere. So it's a discrete function where it's 0 everywhere except at 0, it's infinity. And then he did the integral of that, which should give you the so-called area. And that integral the answer is 1. Well, it was a huge hubbub in the mathematical community I think it was in the 1800s, might have been the 1700s. And people said this is impossible. Well, of course, because you're taking the integral of something with no area and you're coming up with 1. But as it turns out, when you have a electric current and you connect that current, so you have current, you have potential on the line already. Let's say it's your microwave device, right? So your house has potential already set on. You click that button, and yet that cyclotron immediately starts drawing from the circuit. There is a current spike that happens. If the electrical engineer does not attenuate that current spike, it will trip the breaker. And this is a very, very important thing. There's also something, a lot of people don't know this about their home breakers. And I don't know how much you guys know about your home circuit breakers, but there are actually 2 different kinds of, I guess you would call it a short or a protection mechanism. The one most people are familiar with is, lightning strike, or you put too many things on the circuit, and so it flips the breaker off. And then you go, okay, turn off those things, and then you go and you flip the breaker back on. Now, there are 2 specific kinds of shorts that can occur, especially in commercial environments. Both of them are dangerous, but one is particularly more dangerous. One, when you flip the breaker back on, it buzzes at you. And that buzz means that there is a short that it could cause a fire. And so you need to turn it back off, and you need to search all the line to find where that short is happening. The other one is a current short. And when you flip that breaker, it slams back. You have a Dirac delta current short on the line. If you do that again, even 2 or 3 times, 3 times is the so-called average. Never do it more than twice, basically. It can create a current short and immediately explode just like a grenade, 10,000 degrees right in your face. And so they recommend when these guys are, after they finish their tack out, lock out, when they remove the locks and they flip that they stand to the side, because then only your arm would be exploded. Sometimes electricians have been working they have the flashlight in their mouth and they're working, and then they hit that current short is there, and it arcs and it goes through the flashlight, down the guy's throat, and then jumps back into the breaker. That's how powerful these currents are. Now, that is nature approximating the Dirac delta. It can't actually physically do it because electrons they have mass. But it approximates that current short, and it attempts to go to infinity. And so there was a form of proof, but it is not exactly, just like the mathematics. And so the same thing with the dividing by 0. Nature doesn't allow to divide by 0. It creates this asymmetry. And I reckon that this is stuff that has not been talked about by the Donald Scott or anybody over at the Thunderbolts crew, Distenti, anyone else. I think Gareth is the only one who is putting some note to it, that in lab. So you have the Bessel function that Donald Scott describes, and you have Eric Lerner's model, and you have Hannes Alphen's work. But in lab, what you see is that the plasmoid always forms off the center, and the star always builds off center of the Birkeland current in the cosmos. And here we see in Messier 83, the plasmoid is not symmetric, and that is a key point. So these so-called black holes, the pinches that are happening, the magnetic pinches, they're not happening at a true R = 0. the mathematically the r equals 0, but that doesn't mean anything, right? The actual reality doesn't happen at r equals 0. There is a radius that is here, and that's the central thesis. Fortunately, I got to go to work, but hopefully that was pretty good for people.
It was.
Oh yeah, that's interesting. Yeah, I think you're going to have to get photographs of all existing telemetry that we've got out of black holes and compare them for this centrality. And,
yeah, I think that would be a worthwhile paper. Hopefully, one of you guys wants to do it.
Well, I won't want to. I'd be interested in to getting all the data down. I'd be quite interested in getting as many, modern photo shots as that as possible.
Yeah, it wouldn't be hard to show the asymmetry. It's having the longer discussion about it and talking about the mathematics that might be, a little bit more in to take it from the realm of philosophy, like we just had, and take it into the realm of, here's something that we could publish in a journal somewhere. That's going to take a little bit more work, and now not on my list.
But I think as well, it's like Robert's work. If it can be. All right, if you're shown the basic the mathematical processes involved in that, or the matrices, at least you can go back and study them if you understand the maths. If not, as long as you're getting a rational presentation of the argument, which so any normal person can understand in English, and then just present the data sort of really matter of factly, basically, and that's the way that I see it working. Rather than not dumbing it down too much, not going into the mathematical granularity or too much, but being able to a midway point where just like the Thunderbolts do, really, so that there is people can understand it without being a professor, basically.
I'd love it if somebody, because I'll upload this episode, and I'd love it if someone gave it to Donald Scott and got his reaction. It is a problem, like, how do you create the Bessel function? It's great that you have the Bessel function, but how did it start? And Gareth has been the one who really kind of opened my eyes during the electric view days to, this is something that we haven't figured out, is how are these things actually coming about? Eric Lerner, of course, had his model, and I think that Gareth has done a great job in showing what Eric Lerner's model, how it works. But I reckon what's missing is the combination of this issue of the imaginary number, the right-hand rule, the 90-degree rotation, the fact that you don't really divide by 0. You have an asymmetry that's happening. It's probably related to the fractal nature of the universe, and combining these all into a central thesis to how these plasmoids are created. But I know this, when you look at Avebury, when you look at Stone Mountain and Portsmouth, all of them, they clearly, the way they map out these objects are meeting together, they are not meeting at a central point and acting in a symmetric manner. They are going off center. And that is, to me, I reckon that there's some kind of big deal for that. I gotta roll, fellas, but this was a good chat this morning.
Okay, great stuff. Yeah, nice one, Roman. Yeah,